again, ladies and gentlemen, Mr. Donahue here, once more, going over some of those homework problems for chapter 4.4. It's got to do with the redox reaction, so you want to talk about periodic table trends, oxidation numbers, identifying what's oxidized, what's reduced, all that kind of stuff, right? Some of it's a throwback to Regents level chemistry. Some of it is higher level stuff, which, yeah, if you're taking this class, what are you going to do? All right, so first question, 16, in which reaction does the oxidation number of oxygen increase? So you're looking at specifically oxygen. So if you take a look here, if oxygen's in a compound, it's going to have its -2 state, right? So it starts as -2, and if you look at it, well, it's still in the compound, it's -2. In fact, if you take a look, this is just a double replacement reaction. It's not a redox reaction. There can't be a change in oxidation number because of double replacement. They just switch partners. If you take a look at choice B, it's also a double replacement or double displacement reaction. So we know it can't be A or B. If you take a look at C, all right, well, it's -2 here, it's -2 there, and it's again -2 there. All right, so it can't be C. Take a look at choice D. Well, it's -2 here, and since it's oxygen just by itself, it's 0 there, and then it's -2 over there. All right, maybe. And let's take a look at choice E. We know that it's -2 here, and then it's 0 over there. All right, so we're talking about the oxidation number increasing. Well, here it went from 0 to -2, and that's a decrease. Whereas for choice E, it went from -2 to 0. That is an increase. Boom. All right. Let's take a look at problem 17. Set out the choices below. Which one would be best for lining a tank intended to use storage of hydrochloric acid? So this is going to go, crap, wrong button. Go away. Back to our activity table, which you can look up in your book because you got these reference tables lying around. You can also look in there. I think it's table F. I gotta zoom out, man. There it is, table J. Totally lied about being table F. All right, so acids are gonna be right there at the H2. So you want something that's less reactive than acid. All right, well, which one of the choices? Copper, zinc, nickel, iron, or tin is below H2? Copper. That's it. All right, so now we can move on to problem 18. Which species does sulfur has the highest oxidation number? So whenever you have an element just, oh crap, no, what? Put down, pick up, all right. So whenever you have an element just by itself, you know its oxidation state is 0. All right, well here, since it's listed last, it must be that first listed charge that we are familiar with, -2. Here it's listed first, so it's got to be a positive charge of sulfur. Well, each oxygen's -2, and there's 2 of them, so I know it's got to be +4 if the whole thing's neutral. All right, so if I got H2SO3, let me work this one out. I know the whole thing has to be 0. I know each oxygen is -2, and there's 3 of them. I got whatever sulfur is, and I got 2 times +1 for hydrogen. So I get 2 plus whatever sulfur is plus -6 has to equal 0. Sulfur must equal a +4. We know it's +4 here. We're going to do the same thing for K2SO4. I know each oxygen's -2, each K's +1. So we go, all right, well, that gives me a -8 from the oxygens. That gives me a +2 from sulfurs. What does +2 from the potassium. What's my sulfur have to be? +6. Talking about highest oxidation number, choice E. 19. Which of the metals will be oxidized by the ions of cobalt? So we're talking about, doing it again, all right. Talking about cobalt ions plus some metal with a 0 charge becoming some metal with a positive charge and cobalt being neutral. So we're looking for something that's more active than cobalt. Well, that's going to be either remember it or go to a reference thing. And here's cobalt. And well, which one of our choices is higher up than cobalt? Well, we got nickel, tin. Below it, we got iron above it. So that's more active. Copper, again, below it. And then silver below that. So choice would have to be iron. 20. Which compound has the atom with the highest oxidation number? Again, highest, so most positive one. Well, if I have CAS, that's positive 2 and negative 2. Na has to be positive 1. The nitrite ions minus 3. Mg is in group 2, so I know it's going to be positive 2. SO3, I know each sulfur. We got to figure out by looking at the oxygens first. I know each oxygen is minus 2. There's 6 of them, so that gives me minus 6. Got a plus 2 from the magnesium, which means sulfur has to be positive 4. I'm going to do the same thing for aluminum nitrite. Al has to be positive 3. I know oxygen's minus 2. This whole ion has to be minus 1. So I know the nitrogen has to be positive 3. All right, and then NH4Cl. Cl is minus 1. H is plus 1. And therefore, the nitrogens have to be minus 3. Which one has the highest oxidation number? That would be choice C, right? Positive 4 is the biggest one there. 21. Based on the activity series, which one of the reactions will occur? All right, so this is how you do this. If you take a look at A, we have zinc, which is neutral, becoming oxidized instead of manganese. All right, well, let's take a look at our activity table where zinc is and where manganese is. All right, so we see manganese is the one that wants to be oxidizing more. So if we go back to our problem, well, the reaction's ending up with it not being oxidized, so that can't be possible. All right, I'll do one more example of doing that with you. So we've got tin versus copper. Well, which one's more active? I'm going to go back to my chart. I got tin and copper. Tin's more active, so tin wants to be the one that ends up oxidized. It does not end up oxidized, so this can't happen. If you take a look at C, we got Ag versus Pb. Which one's more active? Go to my table J. Got Ag and Pb, so I know lead, Pb is more active. It wants to end up being oxidized, and sure enough, in this problem, it ends up being oxidized, so that one will actually occur spontaneously. 22. The net ionic equation for the dissolution of zinc metal in aqueous hydrobromic acid. So we got zinc metal in hydrobromic acid. That's aqueous. What is that going to end up with? Well, zinc bromide and H2 gas. Zinc bromide is going to be aqueous because we started with it as aqueous, so we got water in the system. All right, well, zinc's not soluble. It's a solid. HBr, we started with H plus and Br minus because it's soluble, right? And then we check out zinc bromide. Well, I can cheat again and look at my solubility tables, all right? If I can actually get to them. Work with me, computer. You can do it. Yeah. All right, so I find bromine, always soluble, except zinc's not an exception. So zinc bromide is soluble. So it's going to end up as Zn plus 2 and Br minus. Not balancing things, not concerned about it at the moment. All right, well, bromide and bromide start and end with, so that's gone. And we start with H plus and it ends up as H2. All right, so I know I gotta worry about balancing this. Do that pretty simply. Start with 2 H pluses, become H2 gas. You got zinc, that was 0. So which one of those choices reflects that? Zinc 0 and 2 H pluses, gives me zinc plus 2, which is aqueous, and H2 gas. Choice D. Bada bing, bada boom. Hope you found that helpful. Feel free to replay it. It's free. I'm going to charge you this time. And, have a nice day while I'm trying to figure out how to close this. There we go.